Hello, everybody. Hope you guys had a great weekend. We're going to start our last new thing for this week's proficiency. So to begin with, we're going to start with a review warm-up. I'm sure proportions for you guys was a long time ago, but I just kind of want to see how you do. So pause this video, see if you can solve these, and then I will go over them for you after you're finished. Okay, so let's go over these and see what you remember. So proportions are done through cross multiplying. So that means you multiply what is across from them. So 3 times x would become 3x. Then you would say 7 times 27, which is 189. And the whole point of a proportion is that you get rid of fractions, and now those two multiplications are equal to each other. So now this is a simple equation that we can solve. We can divide by 3, and we get x is equal to 63. Okay? So same thing on this one. We're going to cross multiply. So I'm going to take 2 times 21, which is 42, 3 times x, which is 3x. We will divide by 3, and we will get x is equal to 14. Okay, so hopefully that's a refresher for you guys on proportions, because we are going to use that skill today as we go through and we talk about this new thing of angle-angle similarity. Okay, so what does angle-angle similarity mean? It basically means that if you have two angles of one triangle that are the same of two angles of another triangle, then those triangles are similar. Okay, but one thing you need to pay attention to is that similar does not mean equal. Similar means their angles are the same, but their sides are different. Okay, because that's where that scale factor comes in. That's where we're using dilations. So usually similarity is found while using a dilation. Okay, so here is an example. Let me make this bigger. Okay, here's an example of similar triangles. Notice that all of your angle measures are the same: 104, 47, 29. And we do not have the same side lengths, because we're not saying that these are congruent. They're not equal triangles. They are similar triangles. So you'll notice that they are all bigger by a scale factor of 2. 4 times 2 is 8. 6 times 2 is 12. 8 times 2 is 16. That's what it takes to have a similar triangle. So all the angles are the same, and then there is a proportional difference between all of the sides. And it has to be the same. We can't times two sides by 2 and another side by 3 and say that that's a similar triangle. It has to be proportional, has to be the same scale factor. Okay, so how do we recognize similarity? The one thing that we do first and foremost is we look and see if all of our angles are the same. Okay, excuse me. So let me grab this one and pull this up for you on my screen over here. And let me get zoomed into it. All right, so we know that triangles are 180 degrees. And so by taking 180, subtracting 102, and subtracting 30, we should know what this angle is. So if I take 180, I subtract 102, I subtract 30, I find that this angle is 48 degrees. Okay, so you can already tell that these are going to be similar because we have a 102, we have a 48, which means this has to be a 30, which means all angles are equal. So these are similar triangles. Okay, we don't have side lengths on this one, but we're just looking at it to recognize that these are similar because their angles are the same. And a lot of times you will have to work backwards from 180 to find missing angles to be able to determine that. Okay, here's another example. Okay, so again, we are going to be working backwards from our 180 to be able to determine this. So we have 180 minus 81 minus 60. And that gives me 39 degrees for this one. So you should be able to tell automatically that these are not going to be similar because there's not a 40-degree angle in here. And so because our angles have to be even, we know that these ones are not similar triangles. They would be close, but they're not exact. And so therefore they are not similar. Okay. What about these two? Are these two similar triangles? Okay, so now we're going to use similarity to be able to figure out scale factors and then be able to find side links. And this is where your proportion work is going to come into play. So one of the things that I highly recommend is either using different colors to figure out which side links match up, or using like circling, squaring, whatever. But that's going to be your biggest battle in similarity and proportions, is figuring out exactly which side links match up. So I am going to use different colors. I think my screen just froze. Just a second. There we go. All right. So it tells us that triangle LEG is congruent or similar, not congruent, similar to MAR. And it wants us to find some information, okay? So I would go through and I would figure this out based on, okay, this is an angle, and this is the side. So I'm going to make this green. So this side is also going to be green because it's an angle. Okay. So then my next side that I'm going to make the same is the side that comes off of my angle here, which has to be this side here because it comes off my one angle, which means that this as well is the same sides. So I've matched up the sides that go together, and now I can start actually setting up some proportions and doing it. But first thing I want to do is I want to find the scale factor. So I need to figure out, how did we get from 32 to 24? Okay, from 32 to 24. So the easiest way to do it is to actually just divide the two numbers. So you would take 32 divided by 24, and that is 4/3, which tells me that if you take and you were to multiply by that, you would get your answer. So 24 times 4/3, which is 4 divided by 3 in the calculator, would get you to 32. So now we need to use that to find the other side links. And we're going to do this by setting up proportions. You could also do it by just using the scale factor. So we could take 21 and times it by 4/3. And it would tell us that this side is 28. And we could go the other way and do 20 divided by 4/3, and it would tell us that this side is 15. But what I really want us to start working on is proportions. And proportions you do setting up the same sides at the same place. So for example, if I was looking for the green side, I would use green over pink. So that would be 21 over 28, green over pink. And then I would do the same thing. Okay, let's get back to that. All right, so we're going to do green over pink. And so that means that we would do the exact same thing here. We're going to call this green X over pink, which is 32. And then we are going to cross multiply and divide. So 28 times X is 28X. 21 times 32 is 672. If I divide by 28, I get, did I set that up right? Oh, you guys, silly me. I set it up wrong. 21 over 24. 21 over 24, x over 32. I was like, this doesn't seem right. Now we're dividing by 24. 672 divided by 24 is 28. So then you see that you've matched that up. Okay, so let's do another one of these. Okay, another one of these. So first of all, we need to decide whether these are similar triangles. And you should notice that they both have a 90-degree angle and they both have one angle that shows that it is the same. So therefore, they are going to be the same. So now we need to figure out matching sides. Okay, so I am going to pull this up. This should be a little bit easier to find matching sides on because just of the shape of the triangle, but those two match. This side and this side match. And then our hypotenuses match. Okay, so those are our matching sides. So we are going to figure out scale factor. Okay, how do we get from a 3 to a 4.5? So we are just going to divide 3 by 4.5. And that gets us 2/3. So our scale factor is 2/3. Okay, this small one is 2/3 of this larger one. But we are going to solve for x because that's what it asks us to do. And we're going to do that by setting up a proportion. Okay, so on this small triangle, we're going to say pink is to blue what pink is to blue. Okay, pink is to blue what pink is to blue, and that's how you would set it up. Now we're going to cross multiply. 3 times x is 3x. 5 times 4.5 is 22.5. If we divide by 3, we end up getting 7.5. So that tells us that that is 7.5. If you want to check your work, then you would take 7.5 and you would times it by 2/3 and you would make sure that it is equal to 5, which in this case it is. Okay. So once you get those color coordinated, it does make it a whole lot easier to kind of figure out where to set your proportion up. Okay. So the first thing I'm going to have you guys work on this one is, first of all, figure out what are the triangles, okay? Then what is the scale factor? Then what is the missing side lengths, okay, using that. So I'm going to give you guys, well, let's say pause for about 30 seconds, and then we'll come back together and talk through this. All right, let's go through this. First of all, you should have said your triangles are ASM and RTI. And I've gone through and I've just kind of figured out which side lengths match up. Okay, so to figure out the scale factor, again, we're trying to figure out how did we get from 10 to 15. So if we are to take 15 divided by 10, we would find that that scale factor is 3/2. Because if I take 10 and I times it by 3/2, I get 15. Okay, so that's how we're getting to it. And then finding the missing side. So we have a missing side here and we have a missing side here. So you would set up 2 different proportions to be able to find that. Okay, so we could take, let's see, pink over blue is equal to pink over blue, and that would solve for this side. We could take, let's see, on this side, we could take green over blue, and it would give us green over blue on this side, and it would get us a proportion. Okay, there's lots and lots and lots of different ways to do this. But the biggest thing is that hopefully you would find that this right here is 12. okay? And that this one right here is 6, okay? And we're going to get more practice with proportions as we go. Okay, we have 2 more slides to get through. And this is what happens if we need to have an actual equation through our proportion. Okay, and how we would solve for that. So again, we need to figure out which sides match up. And then that gives us a little bit more information. Okay. All right, so you should notice that these 2 sides are the same and these 2 sides are the same. So we're going to just set it up that way. We're going to set it as green over pink is equal to green. Wait. I feel like I did something wrong here. Give me just a second. Green over pink. And then green over pink. Never mind. Green over pink. I did it right. Oh, this one's not a very pretty one. Give me a second. I'm going to fix this problem really fast and then we'll come back to it. All right. I figured out where I went wrong. And this is going to be something that's going to be super easy for you guys to do as well. And that is just figuring out which side links are supposed to be there. So we have green over pink. And we have green over pink. Okay, so I just set it up the wrong way. I knew something wasn't right. But so this is where it becomes different, is when you're cross multiplying. So we have 24 times 3, or x plus 3, and 16 times 2x plus 2. If you do not remember how to distribute, I'm going to show you how to do it, but that is the key to solving these type of problems is distribution. So that means I have to take 24 and I have to multiply it through this entire thing. 24 times x is 24x. 24 times 3 is 72. I have to do the same thing on this side. 16 times 2x is 32x. And 16 times 2 is 32. And now I am going to go through and I'm going to solve. Okay, I'm going to move my terms together and solve. So the first thing I'm going to do is subtract 24x. That gets me 72 is equal to 8x plus 32. I am going to subtract 32. And that gives me 40 equals 8x. Divide by 8, and I find that x is equal to 5, which tells me that 5 plus 3 is 8, and 2 times 5 is 10. 2 times 5 is 10, plus 2 is 12 for that side, okay? So obviously way more spaces to be able to make mistakes on these type of problems, okay? So we're going to do one more of these together really quickly and just kind of see how we do. So again, the first thing we're going to look for is going to be putting our sides the same. So obviously our hypotenuses are going to be the same. And then we have 2 bases that are the same. Okay. So we would say pink over green equals pink over green. We're going to cross multiply. So this becomes 15 times x plus 2 and 5 times x plus 22. We're going to distribute. 15 times x is 15x. 15 times 2 is 30. 5 times x is 5x, and 5 times 22 is 110. We're going to combine like terms. I'm going to subtract 5x. We're going to get 10x plus 30 is equal to 110. Subtract 30. 10x is equal to 80. Divide by 10, and x is equal to 8. So that means 8 plus 2 is 10, and 8 plus 22 is 30. Okay. And it should make sense because 5 times 3 is 15. 10 times 3 is 30. That means our scale factor is 3. So we've done our work all correct. Okay. So I know this was a lot. I know that this is not going to be something that's going to be like instant for some of you guys. So we're going to do some practice. There is a 3-question exit ticket that you guys are going to work on. Okay, right here, it shows the 3-question exit ticket. It has you look to see if something is similar, look to see if what a scale factor is, and then look to see how you can solve in a proportion for X. Okay, you do need to get all 3 questions correct for credit. And like always, let me know if you need any help. Because you can see even me as a math teacher can sometimes look at things wrong and set things up wrong. And then I have to take a step back and be able to figure out, oh, okay, I didn't line up my sides correctly. So if you make those same mistakes, it's okay. We're all human. And sometimes those things just happen. So have a fantastic day and let me know if you guys need any help.